Well, we now come to the second law for Kirchhoff's law, and the second law is basically KVL, which is called Kirchhoff's voltage law. So I'll write it down. It is Kirchhoff's voltage law, and then it is in short called KVL. And that law is basically conservation of energy. So this is again a very vital aspect, that this law is based on conservation of energy. So the previous law was a case of conservation of charge, and this is a conservation of energy case. Now the law, as it states, is that if you have a closed circuit, then the summation of the product of I into resistance taken in order should be equal to the summation of the EMF of the whole closed circuit taken in order. Well, this sums up the law. Now, how I can apply this law is best to be understood with help of a real situation, a real example. And I will give you an example. The example is coming up in the next page. And before that, I can tell you that if this can be put as this, E minus IR, then that can be put as V as well. So someone also can write the law like this, but again not in the top there. Again, first you have to write this, then you have to write this, then this, then this. So this is actually the notation of the first law is del I equal to 0 and the second law is del V equal to 0. But I will repeat that this product of I into R is taken in order, and this summation of EMF is taken in order. How to make that order, or what are the rules for making that order, is coming up here as a real life example. So we set the example. We have a circuit like this, and we have two resistances connected like this, small resistances connected like this. Say this is a 20 volt battery, this is a 20 ohm resistance, this is a 10 ohm resistance, and this is a 10 volt battery. Now the first thing that you should do about Kirchhoff's law is never take current on the basis of the direction of the battery. So take the current arbitrarily. Let it be I. Mind you, if this is I, this is also I. And let the current break up here and there. So this is I1 and this is I minus I1. Now I have to consider the loops. Well, what are the loops? The closed paths. Let this be the first loop and let it be clockwise. So the second loop will also be clockwise. Now this is again a very important aspect, that all loops that you consider in a circuit are to be a same directional loop. Can't be that this loop is clockwise and this loop is anti-clockwise. Now the first loop, as you go on, as you can see the current, so in the first loop you are moving in this direction. You see, when I am moving in this direction, the current is coming in the opposite direction. So for loop 1, my direction of moving and the direction of current is opposite. So the sign of IR is negative. So it is minus I1 into 10. I hope you got it clear, the directional sense. As the direction in which I am moving and the current is opposite to that should be put as minus. If it was same, then it would have been plus. Now what is the rule for EMF? Well, now the EMF. You see, I am moving in this direction, but this battery is actually sending current in this direction. So I am moving in this direction. So again I am oppositely. So again this sign is for EMF minus. So that makes I1 is equal to 1 ampere. Now this plus sign implies that my direction of taking I1 is correct. If this was answer as minus, then the interpretation would have been that this actual direction of this current is opposite to what I have taken. Now students, for loop 2, you see this is my loop 2. Where is the loop? This is the loop. You see here I am moving in this direction and the current is also moving in that direction. So this happens to be 20I. You see I am moving in this direction, the current is also moving in this direction. So it happens to be plus 10I1. Now let's see what's the EMF is happening. I am moving in this direction and the actual battery is sending the current in the opposite direction. So students, it's minus, and it's minus 20. So now I1 is 1, so that becomes 20I is equal to minus 30, and I comes to be minus 3 by 2 ampere. Now I hope you understand this negative sign now. The negative sign means the current of I is not what we are actually taking here, but it is actually directed oppositely. Well, that is a good issue to understand, but then again, the directions are far more important to understand. Now, I will give you one more example to make the direction correct. I will come to another example to show you the sense of direction so that you can get it correct. Now, another circuit I'm drawing. Now, this is again a rather simple circuit. So, let us take it. There's a current here, branches up there, it branches up there. There I have a battery. There I have a battery. Say this is of 5 volt. This is of 4 volt. This is of 10 ohm. This is of 5 ohm. And this is of, say, let us take this as something like again 5 ohm. And I have to find this current I. Now the first loop, if I take this current as I1, I should put it as I minus I1. And then the first loop, as I can see, as I am moving in this direction, the current is coming in opposite direction. So for the first loop, I can write minus 5I1. You see, as I am moving in this direction, because the loop is clockwise, as you can see, the loop is clockwise. So as I move in this direction, the current is again opposite, so again minus, so it is minus I. And you see, again I am moving in this direction and the battery sends current in this direction, so that is minus 5. So now everything gets struck off, so it is 5I1 plus 10I is equal to 5. That is the first equation. Now the second equation, the second loop is in this direction. So see, for the second loop, I am moving in this direction. The current is also in this direction. So it is 5I minus I1. You see, I am moving in this direction. The current is also moving in this direction. So it is plus 10I. And here I am also moving in this direction and the battery is also giving current in this direction. So that is plus 4. So now you solve for 1 and 2 and find I. So students, that is the simple reason. I will tell you the direction in which you are moving. If that is also the direction of your current, then the sign is plus. If this is the direction of your moving, the current is at opposite, put it as minus. And the same applies for EMF. So IR and EMF both have same convention for taking sign. That's all for the second law. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.